You're listening to The Interactome, a podcast by a group of young researchers who want to connect you to the world of science by sharing their stories and perspectives. Just in case their bosses are listening, they want to remind you that the opinions expressed here are their own. They also want to remind you not to take anything they say as medical or professional advice, as they are not doctors. Not yet, anyway. Stay tuned about that. And, without further ado, welcome to the Interactome.
Hello everyone and welcome back to the Interactome. Super excited for today's episode. Not sure when this is going to go live, but if I had to guess, it's going to go live during a season we all know very well, and especially if you're on the East Coast, hurricane season. So super
pumpkin spice latte season.
I did actually get one of those when like in August. So
I've been excited.
Yeah, that actually is how you know it's hurricane season, once the pumpkin spice latte. And our guest today is Delián Colón-Burgos. She is a graduate student at Colorado State University. She's going to be talking to us about what it's like to be a meteorologist. She studies hurricanes, forecasting, and I also just want to give a shout out to Colorado State. They have an extremely impressive meteorology program. I think it's like one of the best in the world. So when we decided we wanted to do an episode on this, that was the first university that we reached out to, and we were lucky enough to get Delián. So I'm going to kick it over to her for a little intro.
Yeah, hi everyone. It's a pleasure to be here. I am Delián Colón-Burgos. As Natalie said, I am a PhD student at CSU in the Department of Atmospheric Science, and I am part of the CSU Hurricane Seasonal Forecast team.
Very cool. And then Joe, Sam, any intros for the people?
You first, Sam. By all
means.
I
did interrupt with a pumpkin spice latte thing, so someone's going to be wondering who that person's voice is. Hi, I'm Sam. I'm a biochemist, and so I don't know anything about the weather besides when it happens outside my window, so excited for this episode.
Hey guys, if you don't know me, I'm Joe. I'm an MD PhD student over at Penn. And yeah, this is not my area of expertise either. And I'm very excited to learn all about this today.
And just to give Joe a little bit of a shout out, when he said, hi, we're on Zoom, I can see everybody. He gave a little peace sign. So just so you guys know that, Joe, I don't know if you noticed that you did that.
It's just a habit for me. So, yeah.
All right. I think a great place to kick this off is just a kind of a general kickoff on what is a meteorologist / an atmospheric scientist. When I think meteorologist, and I think Joe and Sam, we were in agreement when we were kind of prepping for this episode, you think about the people who are on TV in front of the green screen, right, pointing at the weather. You're like, oh, you work on the Weather Channel. And speaking to Delián, we realized that that is just not the case. There are so many different ways that this profession manifests. So maybe we start off on just what is your definition of a meteorologist and an atmospheric scientist?
Yeah, so for me, a meteorologist is someone that studies the atmosphere and does it to better understand the weather and climate as well. But as you say, a meteorologist is often known as someone that is on TV presenting the weather, but there's so much behind the scenes that people don't know. And I find this very curious because it's like many people think like a doctor, immediately they think of medical doctor, but it's, not all doctors are medical doctors. You have many doctors that have doctorate degrees in many other professions, but in meteorology, you have meteorologists that do a bunch of things. So other than broadcast meteorologists, you have operational meteorologists. Those are the people that do the forecast that you have in your phones, people that work within NOAA. We have hurricane hunters, for example, that research scientists that fly into hurricanes to better study them. You have people working in the private sector to better understand, or for airlines and working for air quality. There's so many things that meteorologists do that people don't realize. So, yeah, it's a very fun profession, and of course, a lot of people in research trying to better understand the dynamics and how these all these phenomena works.
Yeah, that's fascinating. I didn't know that like airlines would employ meteorologists. I figured they were all just working off of like the FAA report and stuff, and like that's wild to me. I have a couple friends who are like private pilots, and
Mhm.
I had no idea that there was like another layer of weather forecasting that happens for like the big airlines. That's wild to me.
Yeah, even like airlines, it's super essential. Like you see a bunch of planes being stopped by weather, and of course the airlines have to pay passengers if there's like delays and stuff. So it benefits them having a meteorologist in sight to like better predict their delays and everything. And also another field that I think it's super interesting, it's forensic meteorology. There's meteorologists that get hired for to participate in jury for specific events to report on like whether there was hail or not in that specific event, because many insurance companies that would benefit them.
Whoa, that's so cool.
Yeah, yeah, super interesting.
That blows me away. Weather pun intended. Um,
Oh my
but-
gosh. There's going to be so many of those.
Oh,
It's going to
no.
be... I was trying to think of a pun, but I couldn't. It'll come to me. So you had mentioned, too, that CSU is really known for their seasonal forecasting. So I think that that's obviously something we're going to touch on a lot today. But maybe just kind of give us an overview on how that's developed. What is it? How would you kind of explain that to like I guess a layperson like us?
Yeah, so the CSU seasonal forecast, this is the 42nd year that it has been done. So it started with the Professor Bill Gray. He is a very well-known professor in our field, in the field of tropical meteorology. And other than starting the seasonal forecast, he is a huge contributor to many of the things that we know about hurricanes. So it's a true honor to be part of what he started. But yeah, so the seasonal forecast itself, we provide basically a forecast of how active a hurricane season might be. And our first forecast is usually in April. So think like the hurricane season starts in June 1st. So then even in April, we already have a sense of how active a season might be or not. And we provide like the amount of named storms we could have, the amount of hurricanes, and also what amount of those hurricanes could become major hurricanes. So providing those numbers can give people an insight on how busy a hurricane season might be.
And I realize we haven't asked you this, but hurricanes get names. I've always wondered where the names come from. Is that a question you
Yes.
get a lot?
I love this question. It's so cool. Um, because, yeah, so there's like a list that each basin has a list. So, for example, in the US, the National Hurricane Center is in charge of the Atlantic Basin and also the East Pacific. So, let's say there's a list of names for each of the basins, and these names start with the A, so it's in alphabetical order. And it's super interesting because these lists, there's like six lists in total, so it rotates every 6 years. And if there's a major hurricane that impacts a community and has devastating impacts, they retire that name and like replace the name with another name that starts with that same letter. So for example, in 2017, Maria impacted Puerto Rico, and it was a super devastating storm. So then that name was retired from the list, and then it was replaced by another M name that then whenever the year came to rotate again, so whenever that list came again, we had another M name, not Maria anymore.
I'm just picturing just like an Excel spreadsheet of the names,
Yes.
which I think is just a little funny to me. But you brought up Hurricane Maria, and I think in our initial talks you had mentioned that was one of the first things that really inspired you to get into meteorology. So maybe you could touch on that a little bit and just kind of your background in getting into the field.
Yes, so I grew up in Puerto Rico, and being in the Caribbean, you're often, have this hazard of having a tropical storm or a hurricane nearby. So I grew up always being like on the fence of having a hurricane impact us. But at the same time, I was like that weird kid that would get really excited every time there was like something coming. And my parents would be like, oh my gosh, is she okay? Like, what? Everyone's scared and she's like excited for it? I don't get it. So that was me being fascinated by the weather since a very early age. And yeah, Hurricane Maria happened when I was in 11th grade. So it was about to like make a career decision. And I knew meteorology was like a pretty big thing that I wanted to do. But going through that experience and seeing like the devastation in my own community made me realize like this is a big deal and this is what I want to do, and like the need we have for better understanding the systems in order to better provide a forecast to people. So yeah.
It's interesting recording a science podcast. Being a scientist myself, tend to end up talking to a lot of people who were weird kids.
Yeah.
That's a pretty. I was definitely one.
The weather nerd. Yes.
Yeah, like whatever. It's like getting excited about something that no one else in the room is excited about.
Mm-hmm.
It's like I feel like I have some family members who are also scientists, and like we don't agree on a lot of things, but sometimes we'll just pull out, like I have an aunt who will just like, pull out the like start talking about bugs or something, and all of a sudden like I'm there too. I'm like, oh cool, biology, and it's like we're just sitting there, I like staring at a cool bug, and everyone else in the room is like, that's a cockroach. So like.
I think all of us have some kind of story like that for sure, and it doesn't make each individual story any less powerful, in my opinion.
Oh yeah.
I think it really like it's very like obviously you are incredibly passionate about this work, and so like that's one of the reasons we're excited to learn more from you today for sure.
Yeah, that was not dismissing being a weird kid. That was saying
No.
Many of these stories start with someone being like, yeah, so
no,
everyone else was saying one thing. I'm like, wow, this is really interesting. And that's like, I feel like the origin story of like every scientist.
Oh, totally.
Is, it's like there's always that villain origin story happening, or I guess hero origin story.
I wrote my college essay about that actually.
And for meteorologists, it's super interesting because I feel like when you speak or you ask another meteorologist about their story of how they got into it, it's often like some big event or a storm or, something that impacted their community and they saw, the need for studying this further. So.
Yeah, having that catalyst is, like Joe said, really, really powerful. So now let's get into the science.
Yay.
I think when we were doing this outline audience, I think it was funny. We were in the midst of a conversation and Joe and I kind of looked at each other through Zoom and we were like, what is a hurricane? Right? You hear about it all the time. But, it's hard. I think, they're so, I would say, normalized that I think a lot of people don't even think about what they actually are. So I think starting just with a textbook, or not textbook, but like just kind of general definition would be super helpful.
Yes. So in simple terms, a hurricane is a rotating storm. So you have rotation, clouds rotating around a center, and of course, this is big scale meteorological phenomena that can impact many people. So in meteorology, we have smaller scale stuff, but when we talk about hurricanes, it's a synoptic scale phenomena. So it's pretty big. And yeah, as I said, it's a rotating storm and it's characterized by a warm core. So it's kind of interesting because having that center, you usually think about an eye, right? In the middle of a hurricane. Not every hurricane has an actual eye, but having very interesting. It depends on the category, but yeah, it's a warm core storm, and having that air uh, going down in the center, it's what leads to that warm part of it.
And I wonder too, what starts the rotation? Is it wind? Is it, I know they start off as tropical storms. So where does that rotation come from?
Yeah, so the origin of like a tropical cyclone is still a pretty big like area of research. Many people debate that, having a cluster of clouds, it's very important for further developing into a tropical cyclone. Other people think it's more like, having some, like the convection is not that important. It's just like having that vorticity, as we say. But for me, it's essential to have some type of rotation in the atmosphere. So you need a source of rotation, you need a cluster of clouds, and that cluster of clouds comes with having humidity, having ascending air, and then having just the perfect environment for it to organize. And then once it organizes and has some strength, then it depends on what it has on its track that will determine whether it will develop further or not.
Follow-up question to that. What kind of determines exactly, like, so from what you've said here, it makes sense to me, like that's kind of, so those are the initiating things. But what makes, for example, a category 1 hurricane versus a category 5 hurricane? Like, what determines how strong a given hurricane is? I mean, is it just more rotation, more vorticity? Or is it other things? I'm super curious about that.
Yeah, so this is also a very ongoing question in research because it's like, this is a very open science. Like we're still investigating a lot of things. There's a lot of things about hurricanes that we don't actually fully understand. There's sometimes that we have the perfect conditions for a storm to develop and it doesn't. Sometimes we have all the models telling us it's going to develop, like we had last week with one of the storms, and then next day it was like, nope, nothing, zero guidance for further development. So it's
I
still
didn't hear anything about that.
Yes, there was an invest in the Atlantic that had like 80 to 90% chance of development from the National Hurricane Center, and then next day it dropped to 20%. And then it died.
Wow.
So yes, it just shows us how little we know sometimes. But I will say that we know that hurricanes feed off from the warm ocean waters. So I like to think of hurricanes as like a little car motor, and or engine, and their gasoline is the warm waters from the ocean. So they feed up from that water, and that helps them strengthen further. But there's many times right now we have an ocean with plenty of warm water, and in the past few weeks we haven't seen development. So yeah, that's not everything. That will determine whether it develops or not. And knowing if it goes through until a category 5 or 1, or it just really depends on the environment that it goes through and how everything plays out, like the wind shear. Wind shear is another concept that I should probably explain. It's like,
yeah, tell us a bit more about it.
Yeah, wind shear, it's when you have difference of wind with height, so in both magnitude and direction. So think about a storm being like a cylinder in the atmosphere. For it to be strengthened really nicely, you want that core to be aligned vertically. But when you have wind that is like pushing that cylinder and pushing it to not be straight up, that's what we call wind shear. So then it disrupts the structure of the hurricane, and it doesn't let it develop like nicely.
Interesting.
So a lack of wind shear would be beneficial for storm development, along with warm sea surface temperatures and good cloud clusters in the storm that can help further rotate and organize.
That's fascinating, actually.
And I guess, too, one thing that I've kind of been thinking about, I grew up on the East Coast and, heard a lot about hurricanes, but why aren't there hurricanes? I'm in Southern California now. I don't hear about them. Why are hurricanes, and maybe this is a misconception on my part, why are hurricanes more likely to develop in the eastern part of the United States or that Atlantic region over the Pacific?
Yes. Well, actually, in the Pacific, you have more hurricanes than in the Atlantic.
Do you really?
Yeah, usually.
I did not know that.
Wait, that blows
Clearly,
me
I
away.
did not know that.
Yes, it's a much bigger basin, so then you have a lot more cyclones actually than in the Atlantic. Like compared to the Atlantic, the Pacific, it's huge. And yeah, I think we don't hear much about them because NHC, or the National Hurricane Center, is just in charge of the Atlantic and the East Pacific. So then, yeah, we don't hear about the Central and Western Pacific and the Indian Ocean and all the cyclones that happen in Australia as well. So yeah, this is a worldwide phenomenon.
Wow. Here I was thinking it was just the East Coast.
Is this because of like the way like currents work or something, that they're not getting
Yeah,
blown into California
both.
in particular?
Yeah,
Like air
being
currents
a
or water
tropical
currents?
phenomenon, so of course it's gonna develop in the tropics and then they move north. But in terms of not impacting California, it depends a lot on like the large scale flow. So you often have a flow that doesn't go that way, and that's usually why you don't have cyclones going into California.
For some reason, I'm like dredging up something from history class about prevailing winds and shipping and stuff, and like trying to remember like where the winds are. I don't know what sticks in my head, but I just remember
Hmm.
thinking about like where the wind blows at certain latitudes, and I don't know how that works over the Pacific because all of my weather and all of that is like mainly Atlantic and like Great Lakes region. So like I don't have like I understand that tornadoes happen over there and sometimes they happen a little closer to like, that's about as far west as my.
And Sam, you bring up a great point too, pointing to the ocean. I know that the study of interactions between the ocean, like the sea and the atmosphere, are a big, I think, part of atmospheric science. Is that kind of right in that assumption?
Yeah, especially for hurricanes, like a big area of study is understanding those sea atmosphere interactions, because more and more, specifically for hurricanes, knowing that they feed up from these warm ocean waters, it's really important to understand what is happening, right there in that interaction. But at the same time, it's really hard to observe, right? Because it's such a dangerous area. Usually, hurricane hunters don't go really low because it's very dangerous for them. So then we're depending on other observing platforms like drones or buoys, drifters that can gather more information at the ocean surface.
So it's a lot of secondhand data, not secondhand, but like secondary data collection and analysis.
Yes, absolutely.
Yeah.
How do you, maybe this is a dumb question, maybe it's not, but how do you actually like forecast storms using this data? Like how do you?
I don't think that's a dumb question at all. I think that is the question.
Oh,
It is important.
how do you like how do you make a model that has at least like some level of accuracy? Because like clearly we're actually like, my impression as someone like day to day, like we're pretty good at predicting the weather. Like not always 100%, but like we do a pretty good job. Good enough to where I usually feel comfortable trusting the weather predictions that I get as to whether I should bring an umbrella with me or not every day. But like today, for those listening at home, it was a little rainy here, and so I brought an umbrella, and I still got poured on. But it, yeah. So I'm just kind of curious, like, how do we get from this this data to like being like, there's a chance that a storm might happen?
Yes. So we rely a lot on models. So we have these global models that a lot of them are based on physics. So we have equations that describe the atmosphere, and these models can give us a prediction of how our weather will look like in a couple of days. But of course, the further along you go in time, the least like the worse those models get. Usually, that prediction becomes really bad. I would say after 5 days, I take it with a grain of salt. Like I'm like, I don't even trust it that much. But
Well, even what you said at near the top of this interview, just, there was one of 90% chance of developing into a hurricane, and the next day it dropped to 20. So I think that's a really good example of how precarious these predictions can be.
Yep. And that's why observations are super important, because we initialize these models on observations. So if you have errors in your initialization, at first you already have the state of the atmosphere wrong at the beginning, and then of course that increases the chances of having more uncertainty in your forecast. So having really good and high quality observations of these storms is super important, and for bettering that forecast, because we ingest that into the models, we do data assimilation, and then that provides us usually with a better forecast. And there's a lot of research that has been done showing the importance of those hurricane hunters observations and how it has changed substantially for the better, usually a track forecast, both in track and intensity. So they're quite important.
And following up on that, like, what kinds of observations do you include? I'm assuming it's not necessarily like, it's not purely just it is cloudy today, I will put that in the model. Like maybe that's like the level of observation I can make meteorologically. But I imagine it's most likely much more complex than that in terms of like what goes into these models.
I imagine it has like, and this is a guess, but like, would ocean temperature be an indicator? Is that something that is fed in? I guess that's the first one that I thought of.
Yeah, that's quite important. But when I'm talking about like hurricane observations, and especially like aircraft observations, so they do these reconnaissance flights that are specially to identify the center of rotation. So imagine a forecast that you're just doing based on models, and the model is estimating this center of rotation, or you're seeing it through a satellite imagery, right? But you're not getting the full picture if you're not in there. You don't know what's happening under the surface. So having that flight or that aircraft go in and find its actual center identified by the radar that it has in the plane, so you can get a full picture of the wind field in the hurricane. You can get you have drop zones that are these little how do you say, just like instrument that they drop from the plane, and they draw like a vertical profile of the atmosphere in that point, and you get humidity, temperature, winds, and all these meteorological variables that help you describe the hurricane in a complete sense and have a better picture of how it looks actually, other than seeing the satellite imagery that is often not a complete picture.
So, like, just to clarify, because we kind of like eased into this, you're talking about like flying an actual plane into a active hurricane, like, and like I imagine hanging out there for a little bit too. Like, it's not like just like, okay, we're gonna go as quickly as possible, and I imagine that's not going to be the best way to get data. So, like, that's wild. And also, you're talking about, like, those dropped sensors. Are those, like, attached to the plane, or is it, like, radio? Like, what's happening there, too?
Yeah, so it's a GPS system. It's like a little tube, and inside the tube, they have a tube with a parachute. So then inside that tube, you have all these meteorological instruments. You have GPS. So then from the plane, you drop them. They actually fall into the storm, and you get the information through GPS to the plane, and you can get all those observations as the drop zone is going through the storm. And of course, that instrument is lost at the end, but you get that information.
Wow. So it's actually like kind of pricey to.
It is pricey.
Wow. Yeah.
Yeah, it
Man.
is pricey, but the science have shown that it's worth the price for getting a better forecast and saving lots of lives
Yeah,
and
absolutely.
property. So
Yeah. Man. That's fascinating.
That's really interesting. When you say drop into the hurricane, so, like, you're saying a hurricane goes up, like you said, like, up to, like, 12 kilometers. Can they fly over that? Like, what's kind of happening here? Is, like, the plane, like, flying above the clouds and dropping these things, or is it flying through the hurricane? Like, does it matter depending on, like, how big the storm is? Like, if it's a little baby storm, you can just go over it. Like, what's...
yeah, usually they penetrate the storm. So they're going inside the storm, but still they don't go in the what we call the boundary layer. The boundary layer, it's like the first 3 kilometers of, like, from the surface up, and those are like where you have the most turbulence, the roughest winds, and so they don't go down there, but you're still inside the storm. So these are very bumpy rides. Usually, there's a lot of turbulence in those flights, and imagine it's like hours of just going inside the storm, and you're lots of turbulence, and you're gathering data and sending this data to the National Hurricane Center, and they're trying to put up the next forecast. So, yeah.
So with that, from our understanding, you are not in those planes,
No.
which we're very candidly, I'm glad, because that sounds scary. So what does your work look like? Like, how does seasonal forecasting work for you as someone who isn't getting that primary data?
Yeah, so as a researcher, our work is a lot more chill than that, usually. So I work in a computer, basically looking at weather models, I look at observations, and we're generally trying to understand how these work and the nature of these phenomena in general. But relating it to the seasonal forecast, since our forecast is a seasonal thing, we usually do it before the hurricane season. So we're looking at different model runs as well as the current observations from how the sea surface temperatures look, as well as predictors like El Nino, which is El Nino stands for the El Nino Southern Oscillation, so we call it ENSO. It's a phenomenon that happens in the Pacific Ocean, but it has what we call teleconnections across the world. So having an El Nino phase or La Nina phase will alter whether we have more vertical wind shear, which is what I mentioned previously about how rough that wind is in the atmosphere. And for example, if we have La Nina, we're predicting to have a La Nina phase of ENSO. That usually implies less vertical wind shear in the Atlantic, and that would favor more Atlantic hurricanes.
Fascinating.
Yeah, I wouldn't have thought less wind meant more hurricanes. That's interesting. So
Wait.
less wind shear overall means more hurricanes, because the hurricanes have a chance to get windy.
Wait.
They have a chance to make their own system.
Yes.
Wait.
That's
That's
really
crazy.
interesting. I had
Yes.
no idea. That's wild.
Guys.
Like, I just was sitting there like, oh, Yeah.
I have an idea for how we could stop the hurricanes. We make a
Oh
giant
no,
fan
no.
and just like blow it, like a giant fan, and just blow it at the top of the hurricane, so it just like tilts. Or like get enough planes flying into it that it like messes with the wind current or something like that.
Oh,
like
man.
like have enough planes fly at it and then like go up that it just like creates like wind currents that like blow.
I feel like I've heard this before, Joe. I feel like I've heard this before, and it wasn't from a scientist.
I feel like I've heard it too.
It was probably in The Simpsons or something. Like, that's what I'm...
It's gonna work. I promise.
I imagine that the magnitude would require some really, really large fans.
We'll just get some really big planes. Like, just really big. Like, yeah, we could do it, I believe. Right?
Oh, yeah.
Right?
That's how it works. 100%. So I think one thing, too, that I think a lot about, especially when it comes to hurricanes, like we hear so much about climate change and how that is changing weather patterns and how that's just impacting forecasting. What has it been like for you as somebody who, I imagine you've got a front row seat to the climate change conversation and how that's impacting the atmosphere and the ocean? How has that impacted modeling and data collection? Well, I guess not data collection, but like data analysis, right? Like, are the processes that were previously used to analyze hurricane seasons still as accurate as the climate continues to change?
Yeah, that is a great question, and I have the same one. It's an ongoing question because the thing is, like with climate change, we are seeing an atmosphere that we haven't seen before, right? So a lot of our models are based on an atmosphere that is not a reality anymore, and on climatology and events that we are not part of the historical record. So it's hard to predict for something that you haven't seen before.
Yeah.
And of course, it's making our science even more difficult because the things we knew or we thought knew are good predictors or, have worked in the past. This year and last year, for example, have surprised us a lot that all the right conditions are there, and then there's no development, and then there's some storms that look like they don't have the perfect environment, and then they end up developing. So they're just adding a lot of uncertainties to what we do. So yeah, we're learning as we go.
Fascinating. Kind of out of curiosity, kind of sort of going back to the data collection question for a second, like, have you ever like gone out and collected data in any other way, sort of like on your own, or like gone up in a balloon or something, or like I'm super curious.
I don't think that's how weather balloons work, Joe.
Hey, I don't know. I just know they're balloons. That's all I know. They float, right?
Yeah, we do have weather balloons. But yes, I've been fortunate to be on a research ship. So my master's work really focused on understanding African easterly waves, and these are like the seats of hurricanes. A lot of big hurricanes in the Atlantic actually develop from these waves. There's like mini disturbances in the atmosphere, and then they go through the Atlantic and further develop. Some of them don't develop, so that's a big question that we have: why some develop and don't develop, and others don't develop. But last year, I was in a research cruise that we basically crossed the Atlantic Ocean, and in this research cruise, we wanted to better understand tropical precipitation. So we had a weather radar on board that basically was scanning the atmosphere, and we were getting 3D profiles of how the rain looked across our track, and got a lot of really good observations of tropical precipitation. So now that I'm back in the computer, I'm analyzing all of those observations and trying to better understand the properties and organization of precipitation in the tropics. But yeah, in that weather, in that research course, we were also launching weather balloons, as you mentioned, Sam. And these are, I previously mentioned drop suns. They're the same thing, but instead of going down from the plane, they're going up, attached to a balloon instead of a parachute. So it's the same thing. We have these sensors that can measure humidity, winds, and temperature and other meteorological variables, and then we get a vertical profile of the atmosphere as they go up.
That's really cool. Follow-up question: what is it like being on one of these like data collection adventures? Like, as a human being, you're just like
Yes.
out on the ocean. You're like looking for rain. What's it like?
It was amazing. I loved it so much. Yeah, I was 6 weeks at sea, so it yeah, it's interesting. It's a very cool experience. Just like I love rain. I love all of this, right? So it just made me really happy that I was literally engaging with the phenomena that I study, usually back in Colorado, but I wasn't in Colorado. I was like actually in the field collecting my data that I will use for my PhD. So that was just so amazing to be in contact with nature and just like experience it for myself, because I feel like sciences, like atmospheric sciences, sometimes can be like a bit disconnecting. You're in the computer analyzing data, and it's easy to just disconnect from your purpose and why are you actually doing this. And being out there in the wild, in the ocean, being seasick, it
Oh my
was
gosh. I imagine so sick.
having all the things. It was amazing.
Man, I love the idea of like going out on a boat in general. I don't know if I could do it for that long. So like it's
And like, how
Yeah.
big a boat too? Like, I'm like trying to picture this. Like,
So the boat could fit 60 people total. So it wasn't too small, but yes,
But it wasn't that big either. I mean,
it was
it's,
no,
you
it's
know,
not
close
that big.
quarters.
Yeah, it's not that big. I'm gonna say that the first thing when we were allowed to step out, I started running in the port. 'Cause I was like, I can run.
wow.
Yeah, that I missed running. That was one thing. And bananas. I was missing having fresh fruit.
Oh
'Cause
yeah.
yeah, at the end you start with this really good food, and then as you start getting to
It
the end of
starts
the
to get
cruise,
used up. It starts to
Yep.
get worse.
your
Yeah.
lettuce
Yep.
starts becoming cabbage, dried cabbage. Your fruit starts becoming canned fruit. Then you're like, I need fresh fruit in my system.
Yep.
Wow.
Yep.
I'm gonna be honest. I don't know if that's a sacrifice I could make to get this data. Like I need me some clementines in the morning. Like if I don't get those, like
It was a cool
I-
experience.
yeah, it really seems
Yeah.
like it. Man.
So as you're... Oh, Sam, go ahead. Were you going to say something?
no, I was just gonna quip that it feels like anytime we talk to someone about the ocean, it ends up with a story about being stuck on a boat. So it's like marine biology, meteorology. It's like yeah. So after like day 10 of being stuck on this boat with no land or other people in sight, I'm starting to lose it.
Starting to lose my mind a little bit. So as we're in a hurricane season now, what are, I guess, the predictions that your team anticipate? I mean, I guess we're at the tail end of it now, right? It kind of ends, sort of. I think, I imagine you're kind of going, a little bit, but what are some predictions that you have going into this season, or being in this season?
Yes, so this season has been quite interesting. As 2024 was. So here in the past few weeks, we haven't had any development actually. what we usually know as the peak of the hurricane season. So we had some development.
Is September, right? That's
Yes.
why,
Yes.
that's crazy.
Right now, in the last 2 weeks, it was pure peak of the hurricane season, and the Atlantic was very quiet. So we were like, what is happening? And it was a lot of dry air in Africa, a lot of the atmosphere is very stable, so you need a lot of vertical motions to get these clouds forming. So just like the large scale conditions were not right, but right now, as of today, we have a tropical storm that got developed. So I think now going forward for the end of the hurricane season, we're still gonna see some development, and the conditions are looking a lot more favorable for further development. So I don't think we will reach our. Maybe we do. Maybe our atmosphere surprised us. But we predicted an above average season, and it might be average, I would say, maybe a bit above average, but we'll see.
Dare I say it's the calm before the storm.
Yes.
Wow, we've avoided a lot of puns for a long time.
I can't believe I didn't think of that one.
No.
Okay, just for our listeners, Natalie just gave all of us a very proud look. Oh man. Wow.
But I my sentiment stands. Like,
Exactly.
I guess I guess, and this is speculation from me. When you think about fire season, right? And there are like no fires for years and years, they're suppressed. Then you get like a really big fire, right? Because like the conditions almost have been delayed. Is that something that can happen with hurricanes? And maybe maybe the answer is we don't know. But I guess when I'm hearing like the water's so much warmer, the climate is changing, the storms are getting stronger and developing faster as well, I can't help but think that how quiet it is unusual.
Yeah, it's something that we don't know, to be honest.
Yeah.
Like we're learning as we go, as I said, and last season and this season, so 2024 and 2025, I think have been perfect examples of the many things that we do not know. Because it has caught us by surprise that in the peak of both seasons, it has been quiet. And now it's starting to ramp up, at least for 2025. But it's still a question, like, how is it quiet in the peak?
How?
If
Yeah.
all the conditions are usually favorable or generally favorable for development. So, yeah.
Do you have
more
any
research.
hypotheses on that? Again, we don't want to speculate, right? This is a science podcast, but I don't know if you kind of have any.
Yeah, in terms of, I would say something that we're seeing that is quite important. It's like, at least for the peak, we have a lot more Cabo Verde hurricanes. So, as I said, we have these easterly waves that further develop into tropical cyclones. And both last year and this year, the easterly waves have been a little weird. So, I would say the strength and the amount of clouds and cloud clusters that we have within the easterly waves really matters. And I think that's a key component that might be of import, like a good topic to go into further in terms of research to see if the key is in the waves.
So interesting.
It might be a whole new wave of research.
Joe, you're trying to catch up to me, and you can't. So I'm just going to tell you that straight up.
I'm just
I
gonna.
actually want to get back to your pun there, Natalie, with the calm before the storm, because now I'm curious, like, scientifically about that phrase and about the experience of kind of like that weird calm that happens before a storm, and thinking about what you're talking about with shear and hurricanes. Is that like related? Like there's like less wind before a powerful storm because it allows the storm to form better? Is that what's happening? Like,
I think it's more like weather patterns. So you usually have, if you, I think of, our atmosphere as it's an energy balance. So if you have a system that is having or gathering a lot of energy, right, from its surroundings, you're gonna have things like around that are gonna be more calm because that one thing is feeding up a lot of that energy. So I think that could explain that calm before the storm. Um, yeah, you'll probably have a clear or more calm um, environment because you have this one really big feature that is attracting all of that energy and gathering like a little, I don't know what analogy to use, but it's like
Like as
eating up all the energy.
And so, like, from the perspective of us, our sailors on our little ship, like, we are in an area that is nice and quiet and calm, and, like, from maybe, like, satellite imaging, you might see, like, this massive, like, kind of, to use a term I learned today, vorticity, or a massive amount of vorticity, or spinning, like, from the satellite image, and then, like, we eventually, like, would like go into it, and so it would be like the calm, like we saw from our perspective it was calm, and then when we move into the feature it is the storm.
Yep.
Am I even making sense here? I don't know if I am.
I'm also wondering.
You
if
lost
this is
me
just
a little, but I love
Yeah,
the enthusiasm.
Thank
I
you.
love the enthusiasm. I was also just wondering if this has to do with like how fronts work and how.
Yes.
Yeah, like I'm just like. Yeah, I guess now that like I understand, that there's I know that there's like you have like two fronts meet, then you get a storm, and one of those fronts could be calmer, and then you have that like energy differential, and that's what causes the storm. But I guess now I'm like starting to like question what causes the front to form. Like now you started talking since you mentioned I'm like gonna have brainworms about the whole like just be stuck in my head about the whole El Nino versus La Nina thing with hurricanes and that shear wind, because now I'm like, is it the shear that causes the lack of shear that causes the storm and the calm, or is it the like I'm like thinking like is there I don't know, I learned one thing that I learned. I'm gonna walk away with this with one big thing. I'm gonna be playing with it the wrong way for a long time. Yeah, but
I guess my closing thought on just the climate change front, we don't know a lot, but I imagine that there may be, I imagine that the storms that we do get whenever they're there are significantly worse because of climate change due to the warming of the earth.
Yep. Yes, given that as I said, the hurricanes feed up from these warm waters, you have evidence that with climate change, with a warmer planet, you'll have stronger storms. So a greater fraction of storms can reach that major intensity or be more intense. And also climate change poses the question of are we going to have more rapidly intensifying storms? So that's a very big thing that we have seen in the past couple of years, that it's becoming more prominent, that just the storms are intensifying super fast. And of course, in terms of preparedness, it's very hard to prepare a community a day in advance when you did not expect the hurricane to be that intense. So yeah, it's making preparing and issuing warnings even harder. But yeah.
Well, you see those pictures of traffic too, right? Mm-hmm. Something's coming for Florida and people are driving north, but like it's bumper to bumper because everybody's driving north. So I think when you've got 12 hours to get it together and, get out, we haven't talked about that a lot in this episode, but I mean, they're just fundamentally really, really scary. It's like truly horrifying to have to, leave your home and do that. So I guess I just want to say thank you for coming on the show and just like educating our listeners on it. Are there any maybe like parting words of wisdom, looks to the future that you want to share?
Yeah, so I would say for those affected by hurricanes, one thing that I like to say, it's like we create these seasonal forecasts to for people to better prepare and to be more aware of these phenomena. But at the end, for a community, it just takes one hurricane, right? So I could say there's gonna be
Absolutely.
all these hurricanes and be a super active season. But then if a hurricane doesn't go to your area, that's not gonna be an active season for you. But if there's one storm that just impacts your community and devastates your community, that's probably the worst hurricane season for you. So
Yeah.
I encourage the public to not take like just think about always be prepared. You always need to be prepared for the hurricane season, regardless of us predicting an active or not or a below average season. You always need to be prepared. And yeah, especially with climate change, where the uncertainties are just getting bigger and bigger. So keep it in your radar.
Yeah.
Ha ha ha!
And
Oh!
Wait. Whoa. Oh, that's a bit. Yeah. Wow. It almost it didn't
Incredible.
occur to me for a second. I was like, wait, and then,
Yeah, I know. I was
Incredible.
He's like,
Yeah.
what is happening?
Well, it was funny too because I was like, "Does she realize what she just said?" And I was going to be like, "No pun intended." And then you were just like, "Ha!"
pun intended.
I feel like this is a kind of an odd transition, but I really want to put this out there that like you Delián and like so many other people are doing such like this work is so important, and I think
Yeah, it is.
we kind of just like I kind of want to reiterate to our listeners that one thing that we learned through preparing for like this episode and through this conversation is that like there's a lot going on. There's a lot of people doing some really hard work with like trying to make sense out of increasing uncertainty and like literally flying into freaking hurricanes to make sure that we're safe. And like trying to make sense of all this really, really complex data. And I think it's really like I for one really, really appreciate the work that you and everyone in your field are doing to really help make sense of our world and protect us from storms. So
Thank you.
Yeah, it's like one of those
Yeah.
things where, it's you don't think about it until you see it, right? Like you were saying where, there could be predictions that it's a crazy season, and then if people just aren't affected, it's not top of mind. So, yeah, just super important. Thank you so much for joining. This has been a great
Yeah.
conversation, super educational.
yeah, oh my gosh, I
Thank you,
learned so
guys.
much. It blew me away. Sorry,
Ah!
I know I'm using that again, but it's true. So yeah, sorry to rain on everyone's parade. That didn't work either.
No.
Trying too hard.
You're trying to keep up with radar, and you can't.
I can't.
You're trying to keep this. Clearly, Joe, we're beat on this episode. When it comes to puns.
Yeah.
I haven't even tried.
Yeah.
I'm gonna be honest.
Yeah.
Like I'm just like, yeah, no, I don't.
Which is surprising. You usually...
Yeah, which is surprising for me.
Yeah.
I know.
Yeah, maybe next one. But yeah, this has been
Maybe
awesome
next
to have you on. Like this has
Yeah.
been so
Yeah,
fun. So
thank you
so
guys.
much.
It's
Yeah.
been great. Thank you.
No?
Well, to learn more, you can check out the Colorado State University website. They've got a lot of great information on their program, and you can check us out at, and now it's the part of the show where I forget our Instagram handle and our Twitter. So I think it's interactome_media on Instagram and at the Interactome on Twitter.
Woo!
Yay.
Pickell, our editor, is very good at putting that in the show notes.
Okay, so check the show notes. I might be wrong. I may be confused. Regardless, check us out, and thanks for listening.
Cool. Thank you guys.
Thank you.
Bye.